The cosmic challenge, satellites versus space radiation. Space is a harsh environment. There's an invisible threat lurking out there, space radiation. This radiation bombards our satellites day and night. Imagine tiny bullets constantly hitting a car. That's what happens to our satellites. These cosmic bullets cause all sorts of problems. They can mess up electronic systems, degrade solar panels, and even change the satellite's orbit slightly over time. It's a constant battle. Our satellites are tough, but they're fighting an uphill battle. Now, imagine if your car could fix those bullet holes on its own. Sounds like science fiction, right? Well, that's exactly what a new material can do for our satellites. This material can heal itself when hit by cosmic rays. It's like giving our satellites a superpower. They can now fight back against the relentless assault of space radiation. This discovery is huge. It could revolutionize how we build and maintain satellites. It could make them last longer, more reliable, and even make space missions cheaper in the long run. To understand why this is so important, we need to dive deeper into our cosmic enemy space radiation. Unveiling the invisible threat. What are cosmic rays? Cosmic rays are high-energy particles that zip through space at nearly the speed of light. They come from all directions, some from our sun, others from distant stars and galaxies. They're invisible but pack a punch. These particles are mostly protons, but can also be electrons or entire atomic nuclei. They're incredibly energetic, with some having more energy than particles in our most powerful accelerators on Earth. When they hit something, they can cause serious damage, like a microscopic wrecking ball hitting your satellite. Earth's atmosphere protects us from most cosmic rays, but satellites don't have that luxury. They're exposed and take the full brunt of this cosmic bombardment. Over time, this causes problems degrading materials, causing glitches in electronics and flipping bits in computer memory. This is why space radiation is such a big deal for satellites. It limits how long satellites can operate and forces us to build redundancies into our systems. It makes space missions more expensive and complex. But now, with this new self-healing material, we might have a solution. We might have found a way to fight back against the cosmic onslaught. A material revolution, the self-healing wonder. Enter the hero of our story, the self-healing material. It's not just tough, it's smart. When cosmic rays hit it, it doesn't just resist damage, it repairs itself. It's like having a team of tiny mechanics constantly fixing your satellite. The material is a special kind of polymer with a unique structure. When cosmic rays hit it, they break some of the chemical bonds. The broken ends are designed to be attracted to each other, naturally wanting to reconnect. This reconnection happens fast, in just a fraction of a second. The material is whole again, ready to face the next cosmic ray. This process can happen over and over. The material doesn't get tired or wear out. The healing process actually makes the material stronger in some ways. Each hit and heal cycle toughens it up a bit. So not only does it repair damage, it gets better at resisting future damage. It's a material that learns and adapts. It's perfect for the harsh environment of space. This self-healing wonder could revolutionize how we build and maintain satellites. It could make them last longer, more reliable, and even make space missions cheaper in the long run. Nature's blueprint inspiration behind the discovery. Nature is full of wonders and solutions. The scientists who developed this material looked to nature for inspiration. They studied how living organisms heal themselves, an approach called biomimicry. They looked at how our skin heals cuts, how trees repair damage, and how some lizards can regrow their tails. All these natural processes involve materials that can reorganize themselves and rebuild their structure when damaged. Translating this to a synthetic material was tricky and took years of research. The scientists had to design molecules that could move and reconnect, ensuring this process would work in the vacuum of space. They tested it under extreme conditions, facing many challenges. They tried many different approaches, some failed, others showed promise but weren't quite right. It was a process of trial and error, but they persevered. They kept refining their ideas and testing new combinations. Finally, they hit upon the right formula. They had created a material that could truly heal itself in space. This self-healing wonder could revolutionize how we build and maintain satellites. From lab to orbit, the journey of innovation. Creating the material was just the first step. The next challenge was testing it. You can't just send something into space and hope it works. The stakes are too high and the costs are too great. So the scientists had to get creative and simulate space conditions on Earth. They used particle accelerators to mimic cosmic rays, bombarding their new material with high-energy particles. They watched how it responded and measured how well it healed. They also tested it in a vacuum, subjected it to extreme temperature changes, and ensured it could withstand the vibrations of a rocket launch. Each test brought new challenges and led to improvements in the material. Finally, after years of testing, they were ready for the real thing. They sent samples of the material to the International Space Station. Astronauts there conducted experiments, exposing the material to the actual space environment. The results were exciting. The material performed even better than expected. It was healing itself in real space conditions, a triumph of science and engineering. Shields up. How self-healing materials protect satellites. So how exactly does this material protect satellites? It's all about layers. Satellites aren't just covered in a single material, they have multiple layers of protection. Each layer has a job to do, and the self-healing material becomes a key part of this defense system. The outer layer is usually a tough, heat-resistant material that protects against space debris and thermal extremes. The self-healing material forms a layer underneath this, acting as a second line of defense. When cosmic rays penetrate the outer layer, they hit the self-healing material where the magic happens. The material instantly repairs any damage from the cosmic rays and absorbs some of the energy from the rays. This means less radiation reaches the sensitive electronics inside the satellite. It's like a smart shield that gets stronger with each hit. Because the material can heal itself, it lasts longer, meaning satellites can stay in orbit for longer periods. They need less maintenance and are more reliable. All of this adds up to big savings, making space missions more cost-effective. It opens up new possibilities for what we can do in space. Beyond satellites, expanding horizons in space exploration. The potential of this self-healing material goes far beyond satellites. It could revolutionize space exploration in many ways. Think about space stations. They face the same radiation challenges as satellites. This material could make them safer and more durable, allowing for longer missions in space. What about missions to Mars? The journey takes months. Spacecraft are exposed to cosmic radiation the whole time. This material could provide crucial protection, helping keep astronauts safe. It could be used in spacesuits, making spacewalks safer. This material could be key to exploring even deeper into space. It could be used in probes sent to study distant planets or asteroids. Imagine habitats on Mars that could repair damage from dust storms. This self-healing technology opens up a world of possibilities. Earthbound benefits spin-offs from space technology. Space technology often leads to unexpected benefits here on Earth. Scientists are exploring how self-healing materials could be used in various industries. Imagine a phone screen that fixes its own scratches or a laptop that repairs internal damage. This could reduce electronic waste, a growing environmental problem. The automotive industry could benefit too. Cars could have paint that repairs its own scratches. Space research can lead to innovations that benefit us all. The road ahead, future developments and challenges. The discovery of this self-healing material is just the beginning. Scientists are working on improvements. They're exploring ways to make it heal faster and work in harsher conditions. One area is combining this material with other advanced technologies, for example, integrating it with sensors to detect damage and trigger healing. But there are challenges too, like large-scale manufacturing. It's still expensive to produce. We need more long-term data from space tests, and adapting the material for different uses like spacesuits or Mars habitats. A new era of space resilience, embracing the self-healing future. As we stand on the brink of this new era in space technology, this self-healing material isn't just a cool invention, it's a paradigm shift, moving from passive resistance to active healing, making missions more reliable and cost-effective. Imagine swarms of small self-healing satellites working together. But perhaps the most exciting aspect is what this represents for human ingenuity. We created a material that can fight back, that can heal itself. It shows that we can overcome the challenges of space exploration. We can push the boundaries of what's possible.
So hit that subscribe button, ring the bell for notifications, and let's turn the page on a new adventure together. Get ready to experience books like never before, only on VBook 360. Like, comment, and share to support the channel and keep the video magic alive. Thank you for stopping by. And remember, every video has a story, and every story deserves to be shared. See you in the next video.